All right. Good afternoon, everybody, and welcome to EORN's second webinar, a webinar for Ontario municipalities highlighting successful implementation case studies of decentralized water and wastewater systems in Eastern Ontario and beyond. Before we get started, I would like to acknowledge that we are coming to you from the traditional territory of the Anishinaabe, the Haudenosaunee, and the Huron-Wendat peoples. We acknowledge our shared obligation to respect, honor, and sustain these lands and the natural resources contained within. We're very excited to have a number of highly qualified panelists with us today, all experts in decentralized water and wastewater management, and all coming with various views, from builders to operators, from developers to municipal owners. Following our first webinar in October of 2024, we issued a survey, and the number one topic highlighted in the feedback that we received from you was that you wanted to see successful implementations of these systems in Eastern Ontario, and that's what we're doing today. Depending on time, at the end of the webinar, we will try and address questions that you can pose in the Q&A section. Note that you are able to vote on questions that are being asked in the Q&A section. That's called upvoting. And you can upvote a question by tapping the thumbs up. And if we run out of time, we will address the questions with the most votes. And we will also answer any questions if we can't get it after by email. Please note that this webinar is being recorded and posted on EORN's YouTube channel. And that's also where you can find our initial October 30 webinar. And following this webinar, you'll receive a survey, and we encourage you to share your experiences from today. And now I'm very pleased to introduce Jason St. Pierre, EORN's CEO, to say a few words to kick off this webinar. Jason?
Thank you, Marco. Good afternoon, and thank you for joining us today for our second webinar in a series dedicated to raising awareness and sharing knowledge about decentralized water and wastewater systems. This webinar is a direct result of the ongoing efforts led by the Eastern Ontario Regional Network, also known as EORN, to advance solutions for rural and underserviced communities. Today, we are excited to delve into some real-world success stories from Eastern Ontario that showcase the potential that decentralized systems can have on transforming rural development and communities. We'll be looking at how these innovative approaches have already had a positive impact on our communities, addressing long-standing challenges in ways that are both cost-effective and sustainable. Some of you might know EORN supported the creation of the newly formed organization called Rural Impact Canada, which is focused on providing municipalities with clear, practical roadmaps to overcome development challenges. This important initiative has been made possible with funding from the Canadian Mortgage and Housing Corporation's Housing Supply Challenge. For further information, you can visit the Rural Impact Canada website at ruralimpactcanada.ca. I would like to thank you for being part of this webinar, and a special thank you to our panelists for taking the time to share their insights and experiences. Today's discussion will provide us with invaluable perspectives on how decentralized water and wastewater systems can create long-lasting positive change in our communities. And now, without further delay, I'll turn it over to Marco to guide us through today's session.
All right, thanks, Jason. Next, I would like to introduce the panelists. And today, I'm just making brief introductions, but their full bios are posted on our website at eorn.ca/webinars. First, I'd like to introduce Josh Blockhouse. Josh is a project manager and partner at Sheldon Creek Developments, a property development company based out of Orangeville, Ontario. For the past 5 years, Josh has been managing the decentralized treatment facility in Carp. Currently, Josh is working on the very early stages of a 220-unit tiny home community that will also be serviced by a decentralized wastewater system. Next, I would like to introduce Jim Hotchkiss. Jim is the CEO of NRO Systems Group Incorporated, specializing in advanced water purification, wastewater treatment, and water reuse across Canada, the US, and the Caribbean. With extensive experience and leadership roles at various water companies, he has a strong background in both academia and the water sector. Next, I would like to introduce Lindsay Wolfenberg. Lindsay is a water and wastewater professional with over 10 years of experience in the operation and management of decentralized systems, and she plays a key role at Clearford. Lindsay fosters strong relationships with regulatory agencies and contributes to discussions on sustainable water management as a member of the Ontario On-Site Wastewater Association. And finally, I'd like to introduce Chris Angelo. Chris is the Director of Public Works and Environmental Services at the City of Quinte West since 2007. He holds a degree in environmental science from Carleton University and a civil engineering technology diploma from Loyalist College. Chris is with us to talk about the Stonecrest Estate wastewater treatment plant project in the City of Quinte West. So we're following a little bit of a different format this time compared to our October webinar. We're going to give every panelist about 5 minutes, 5 to 7 minutes, to introduce their success story. And after that, after everybody has presented, we are going to have a bit of an open session. And in part, that session will be fueled by questions you can pose in the Q&A. So without further ado, we're going to start right in our own backyard with Chris, who's coming to us from a municipal perspective. Chris is going to speak about the Stonecrest Estate wastewater treatment plant in the City of Quinte West. Chris?
Thank you, Marco, for that kind introduction. As Marco mentioned, I'm the Director of Public Works and Environmental Services for the City of Quinte West, and I'm here today to talk to you about a unique story that we have in a partnership that we've had for a number of years with a local developer and a local school board in the development of the Stonecrest wastewater treatment plant in the City of Quinte West. For those of you that are familiar with Quinte West, we have an area known as the South Sydney area, also known as the Bayside area, that's been identified for significant growth for many, many years. In the mid-1990s, the province of Ontario partnered with the then Township of Sydney to provide a water treatment plant in this area to support growth and settlement in the South Sydney area. However, wastewater remained a challenge in providing that service to this area. At the time, provincial policies allowed for some partial service development. Over that time, the province has shifted away from partial service development, meaning that new solutions for wastewater treatment needed to occur to allow growth and significant growth in all of our communities in Ontario. So in 2016, a local developer and the Hastings Prince Edward School Board proposed a plan to the city to look at constructing a modular, expandable, decentralized wastewater treatment plant with the goal of building 143 new single detached and semi-detached homes in the South Sydney area, and as well provide surplus capacity to accommodate an existing subdivision that was on municipal water and septic systems, and as well dealing with a local high school that was serviced by a failing septic system. The project details involved transferring school board property to land to the municipality to facilitate the construction of this wastewater treatment plant within the source water protection area. The developer at the time engaged Nuterra to design the wastewater treatment plant at that time, which really contained a membrane reactor system with flat screen membranes. Is really a design based on an operator-friendly membrane system, operator-friendly in terms of a packaged plant. Included screening, biological treatment, and membrane filtration. The developer was proposing at one time using sea containers for the treatment plant, but due to the multi-phased approach and 2 phases being proposed at the time, a dedicated building was constructed to house all the equipment inside. The first phase was looking at a total capacity of 213 cubic meters a day, with total capacity at the end of phase 2 being 425 cubic meters a day. The premise being that the school board, the reason why the school board transferred the property to us was that was a housing their existing septic system that was failing. In terms of the total cost, the phase 1 total construction cost of the decentralized plant was around $1.8 million, and phase 2 being about $2.98 million. We had blended at the time the operational costs of the plant with our larger facilities happening that were in place in Trenton and Frankfurt, so that we'd have one rate structure throughout the entire municipality. We're really happy with the performance of this plant to date, with the effluent limits meeting the required discharges, especially in the source water protection zone. This plant really enabled the construction of 143 homes to start, but with the addition of phase 2, enabled the construction of an additional 98 homes for a total of 241 new residential units in this area. It also facilitated construction or the connections of an additional subdivision to the east that was on septic systems, and eliminated the costly septic system that was being maintained by a local school board. The lands also enabled the construction of a new hospice in Quinte West that was much needed for our community. Staff and decision makers need to be open to decentralized wastewater treatment facilities, especially in face of ongoing housing crisis that we have in our country. Traditional infrastructure approaches may not always be feasible or efficient, particularly in rapid growing rural areas. Leaders must embrace and support emerging technologies that offer innovative solutions for wastewater treatment and management. And that's something that we've done as part of our city, and taking a proactive leadership role in encouraging developers to explore and implement new technologies within our community. By fostering an environment that welcomes innovation, we've helped pave the way for sustainable and cost-effective solutions that benefit both communities and the environment. It is crucial for other municipalities and stakeholders to adopt similar forward-thinking ideas and a mindset, ensuring that regulatory frameworks and policies support rather than hinder technological advancements in housing and infrastructure development, especially in light of the province's housing crisis, which we're all under at this point in time. One of the lessons that we learned from this decentralized wastewater treatment plant construction in Quinte West was a unique partnership that we developed with another developer for another decentralized plant in Quinte West along its western boundary. The Youngs Cove development proposes and is constructing 426 new housing units in our community. What we did with this development is we learned great things from the first decentralized plant, and we wanted to ensure that the plant was self-sustaining over the term of its construction. So in this light, we partnered with a developer where the developer is supplementing the revenues from the difference between what the connected users are paying towards the annual operating costs and the difference in the actual operation cost of the plant. And until the plant is assumed by ownership by the municipality, the developers are making those annual contributions to bridge that gap between what we're receiving from revenues versus what the actual cost of the plant is. Currently, the Prince Edward Estates development, the Youngs Cove development, has a separate higher wastewater charge than our blended system, but we're currently looking at a blended service rate for all the connection systems in our municipality. Innovation often sparks a snowball effect, and this project was no exception. Beyond providing a cost-effective wastewater solution, a decentralized wastewater facility facilitated 241 new units in Quinte West, a new hospice, a valuable partnership with a local school board and local developers, and another decentralized facility in Quinte West. These initiatives demonstrate a collaborative approach to the development of treatment plants in rural areas, supported much needed housing units in our community. Moreover, this forward-thinking approach paved the way for a broader adoption of new technologies in our municipal operations. By embracing innovation, the City of Quinte West continues to enhance efficiency, sustainability, and service delivery across its infrastructure and its operations. Thank you.
All right. Thanks a lot, Chris. That's a really interesting case study. I definitely myself have a few follow-up, and anybody after we've all spoken, we can get back into it. But proactive thinking, it's sometimes difficult at a municipality, right? If it's bound by regulation. So it's really a good approach. All right. Next, I would like to ask Jim of Aerno Systems to speak about a project that's a little bit further afield Yet it's very relevant, especially to some of us in remote areas in the province. Jim?
Great, thank you, Marco. Yeah, as Chris introduced, the technology works extremely well on allowing you to accelerate development, particularly in this case in a greenfield application. The technology is widely used, however, around the world on everything from greenfield to brownfield, from sanitary to high strength industrial wastewater, you know, would be craft breweries, food and beverage, any other kind of food and beverage applications. And so, you know, while Chris introduced a greenfield one, I'd like to focus a little bit on a brownfield retrofit that we actually did a little bit east of where you are and a whole lot south in the BVI. The hotel that you see here was for 75 years. This is where the heads of state of all the Caribbean nations used to go for their meetings. It was a beautiful resort that happened to get almost completely demolished by Hurricane Irma in 2017. And you can see on the second photo there some of the damage that was sustained by the buildings that were close to the beach. This facility had an old rotating biological contactor, RBC, wastewater treatment plant, that was also badly damaged, let's say, completely inoperable. So we were asked to come down and take a look at the facility and suggest what could be required to get the hotel back in order. So we went down on site and looked at the application. There were some key criteria. It had to be a low energy facility because electricity rates in the BVI are some of the highest in the world. It had to be durable, and because it's less than 100 meters from the sea, so you couldn't use conventional steel products or anything like that. So everything had to be either non-metallic or corrosion resistant. So all of the tanks had to be, in our case, FRP, fiberglass, or stainless steel, and all the structural steel had to be stainless. It also had to be modular because the hotel was continuing to expand, and so it was designed to grow as the hotel grew. So basically we developed a design around a membrane bioreactor, similar to what Chris had described for Quinte West. In our case, we use hollow fiber membranes. That schematic that you see at the third image there is basically what it is. The biological treatment is done in two fiberglass silos, which were shipped to site. The wastewater, as it leaves the bioreactor, goes into a membrane tank, which is the tank you see on the extreme left, which is full of hollow fiber membranes, and it recirculates. And so it basically mimics the digestive system of any mammal. We have beneficial bacteria that break down the organic material and basically produce a reused quality water, which was another criteria of the project, because all of the water treated from the toilets and the kitchens had to be recycled back to either landscape irrigation or to the laundry wastewater. And with the landscape irrigation, it had to have no odor whatsoever, because if you're renting a room at $600 to $1,000 a night, you don't want to smell sewage when you come out first thing in the morning. So no odors on the treated water. And also the wastewater treatment plant was immediately adjacent to some very expensive villas. And so no noise would be allowed from the system. So we designed the membrane bioreactor. On the last slide here, on the right-hand side, this was fabricated at our facility and shipped to site. So we designed, built, and were ready to ship the entire system in 12 weeks. It was shipped to site, and it was installed and commissioned in 2 weeks after arriving on site. Concurrently, the client was building a shelter for the building or for the system. So the entire equipment fit into a facility that was 4 meters by 12 meters. So a very compact system. This was designed to treat 100 cubic meters per day, 25,000 gallons per day. And the entire system was shipped to site for a total capex of 300,000 Canadian, or roughly $3 Canadian per liter of treated capacity. Some of the challenges that we experience here, because it was remote, and it's no different from a remote community in Northern Ontario or Northern Quebec, is whatever you require, it has to be shipped with the package. You can't just go next door to Lowe's or whatever and pick up a valve or a piece of pipe. So everything that we required, tools, because they don't have Robertson screwdrivers down there. So if you need Robertson screws, you got to bring the bit with you. Everything had to be shipped with the package. The local labor is relatively unskilled, and so this entire system was put together by the general manager of the hotel and one of the staff that normally looks after the property. And also, it's not easy to get technicians on site to fix anything, so you have to keep it simple. So if you're going into a rural environment, you have to estimate what you need. You have to make sure everything is there. Whatever spare parts you need, whatever backup equipment, it has to go with it. And it has to be simple, because you can't afford to bring people into a remote location to fix a PLC code that's not quite working. And so that was sort of what we learned from this example, which we now do for most of the systems that we build. Some are even closer than British Virgin Islands. Some of them are right across the lake from where you are, Marco, in New York State. Even there, you have to figure that you can't go next door and get a piece of equipment. So we try and make sure that everything that's required is there, and that we keep it super simple. But that last issue is really critical for remote locations.
All right. Thanks, Jim. I can't believe the 12 weeks, getting ready to ship in 12 weeks and then install in 2. It's and the fact that you need to ship everything with it. That's also something you wouldn't think of, especially in the rural areas. So no, it's a really a relevant example. Thanks very much. Next, I would like to bring it right back to Eastern Ontario and invite Josh to speak about managing a decentralized treatment facility in Carp. Josh?
Thanks, Marco. So I'm speaking today about another fairly unique project. This is in the west end of Ottawa in the village of Carp. So this project started way back in the early 2000s when the city of Ottawa sold the Carp Airport, which sat on about 1,000 acres, with the intent that the developer that they sold it to would maintain the airport, as well as develop an airport accessory commercial business park and a residential community on the property. One of the big issues at the time was that the village of Carp had limited water capacity and no sanitary capacity for this development. So the idea was brought forward to bring a trickle feed water main from the village, which would fill a large holding tank, where it would be rechlorinated, pressurized, and sent to the development from this treatment facility on site. This still left the issue of sanitary, though. So after exploring some different servicing options, including private servicing options, it was decided to go with a communal surface discharge system. So after going through the EA process, the detailed design, the ECA process, and then establishing a municipal responsibility agreement with the city of Ottawa, we finally broke ground on the construction of a new Terra-built wastewater treatment facility in 2017. So we planned for a total of 5 modules. 2 of these modules have already been installed and are in use today. And each of these modules is capable of treating 186 cubic meters of wastewater per day. I'm probably better off leaving the technical elements of it to maybe Lindsay there. But at the end of the day, the wastewater gets treated to a point where it goes into a ditch next door. The entire development, both the residential and the commercial sides, are on a condo. So the condo is responsible for hiring an operator of the plant, and in this case, they have hired Clearford. And as well as maintaining and pumping out individual tanks, the solids at the tanks at each of the properties. Maybe at this point, Kristen, are you able to share a map of the site? So currently, so yeah, this is the whole 1,000-acre site. Currently, the residential subdivision, we're approved for 342 homes on the left side of the map there. About 200 of those have been built and are occupied. The commercial is on the right side of the map there, in the blue and purple and brown. The brown's being completed. Phase 2. We'll be looking at putting the roads and services in this fall. And then right in the middle, within that small triangle where Kristen's got her cursor there, is where we've got the treatment facility. And then the white in the middle, the whole white area is the core airport, which is still in use today. So I often get asked about this development that we've been working on because it's quite unique. And I always say that I think it's a great system. If we would have had to wait for the city of Ottawa, the village of Carp to upgrade their sanitary and water, this never would have happened. We've had our fair share of maintenance, as any, I think, wastewater treatment facility would have, with a lot of moving parts, but we've never had any major issues, and we've always liked the fact that we can add modules as we go. Every time we want to add more residential or commercial, we can just add another sea container and keep things moving. Thanks for your time.
Thanks, Josh. Definitely have a follow-up question on that, but let's save them for our discussion at the end. And just to remind everybody, even basic questions, don't hesitate. Drop them in the Q&A. We have one, but we can handle a few more. So this is your opportunity to hear from the experts. And after this, I'm going to go to Lindsay. And Lindsay is going to say a few words about operating these systems right here in Ontario, including the CARP one. Lindsay?
Thank you very much. So I wanted to say thank you to Marco and the team at EORN for hosting these webinar panel discussions. I think it's a really important conversation and gives examples to everyone on what the different options really are. So I know that the other panelists really focus more or less on one project. I'm going to talk a bit more in general terms as to what we see as operators of the decentralized facilities. So as an operations company, we tend to enter into these projects, really at various stages based on our operational experience with the different technologies. So sometimes, such as in the case of CARP that Josh was just speaking to, we're brought on board or consulted really early in the process. So Clearford was part of the early plans in CARP, reviewing with Novatech, who was a consultant, as well as West Capital and Sheldon Creek, how the water needed to look and what the wastewater treatment needed to be to service what the development needs were going to be as that site was being built out. So in that, sometimes we'll assess the different treatment technologies in order to suit the best application. We'll support development of the municipal responsibility agreement or the MRA. We can help with the EA, the ECA process, all of that. Other times, we're brought in midway through the process. It might be when the client is looking to include operational costs in their overall budgets, or to review the design, such as in the case of CARP, and provide feedback from our perspective. When we're reviewing the design plans, we're able to really catch items that are really strictly operational and that are easily missed sometimes in those early engineering phases. things like sampling or flushing points, fresh water supply to the plant for cleaning of different equipment, also things like chemical storage, other health and safety related items, that sort of stuff. Oftentimes being able to review these items can actually impact and improve the long-term operational cost to a facility. Sometimes you have to add a bit more capital in the beginning to have a more effective and cost-effective sort of long-term operations. So I know a lot of my fellow panelists, we were discussing sort of residential developments or resort developments in the case of Jim. But I wanted to also mention that, as an operations company, we see decentralized systems really successfully used also for commercial and light industrial development as well. Typically development of items such as warehouses, distribution centers, recreational properties, like golf courses, different applications that really do require a large amount of land requirement. They tend to develop outside the urban boundary, which really makes them great candidates for decentralized solutions to meet the utility needs. So as an operations company, excuse me, Clearford, operates, or we support the operations for both decentralized water and wastewater. In the case of some of our First Nations or federal and national defense facilities, we've actually been supplying sort of support services. So what this can look like is supporting their on-site staff. They may already have one or two operators who are capable of doing the operations for the treatment plant, but it's really challenging to successfully run a system with only one or two staff. People get sick, they need vacation. So we're able to provide a support service into that. So it really becomes sort of a complementary relationship in that case. I wanted to give a little bit more detail too on some of the systems we operate. So I'll talk a little bit more about CARP in a minute, but a good example is Ballantree. I don't know, Kristen, do you want to throw the pictures up? So these aren't necessarily in Eastern Ontario, but I think when we're talking about these applications, the concept of just being outside the urban boundary in a more rural area is universal across the province. So Ballantree is a really good example of how successfully decentralized treatment can be used to support development and growth. So Ballantree is, you can see that bottom photo. So it's located in Stouffville, and it consists of an 18-hole golf course as well as 800 condo units. So the ability to grow the site was directly related to the ability to service the wastewater needs on site. So in some cases, we find it's a lot easier to extend the municipal water connection rather than the sewage. And this is true for the case of Ballantree, where their water is serviced municipally, but sewage is actually provided through the decentralized sequencing batch reactor system. So the installation of this larger scale wastewater system, which is rated for up to 1,045 cubic meters a day, really allowed the site to grow and develop to include the current 800 condo units. Attached to that as well is that the Ballantree Public School and Community Center are both connected to the wastewater facility. So this really does show that, inclusion of a decentralized treatment services can really support multiple aspects within a community and really help for that development and growth. So Ballantree and the municipality of Whitechurch of Stouffville was really early to realize that decentralized was a good solution to support the development needs in a really sustainable manner. Clearford's been involved in the operation of that site since 2022, but the use of the actual decentralized treatment system goes back to 2004 when the plant was first installed. So you can see that, they were kind of pioneers in the sense of how this could help their community and help the development grow. Another one I wanted to touch on is Shirkston Shore. Again, it's in Niagara. However, Shirkston Shore is really a city within a city. It is a seasonal resort community, for those who aren't familiar with it. And it consists of around 1,500 seasonal sites, along with a water park and restaurant. So when I say it's a city within a city, it's really its own entity. It's actually one of our longest serving clients as well. And it's an example of how, with early involvement, Clearford was able to provide, really supportive input into the design and the development of their decentralized treatment systems, as well as support the growth as that resort property grew. So in the early I was gonna say 1900s, but 1990s, which still feels really long ago, Clearford actually supported the original wastewater treatment design and was able to help with that installation as that resort property was rapidly growing. They weren't able to continue hauling sewage. That wasn't a sustainable option. So in the early 2000s, in the late 1990s, the first train was installed. It's a package plant as well. Not quite like Nuterra's package plants, but it's a Napier Reed system for extended aeration. So in the early 2000s, the resort continued to grow. So they were actually able to add an expansion with a second train. And Clearford's currently involved in supporting the third expansion so that the site can meet its final growth numbers. On the water side, they were actually faced with a boil water order from the ministry, and Clearford was able to, work within a month to get a temporary emergency water treatment plant installed. And then within 6 months, completed the full design and build effort for a new 4,500 cubic meter a day membrane microfiltration system. So to this day, Clearford is still the operator of this system. So alongside with these sites, you can see, and with what Josh was talking with CARP as well, there's a lot of opportunity, to be able to have sites that are outside that urban boundary to grow and develop with using communal systems. So thank you very much, and we welcome any questions you guys may have.
Thanks so much, Lindsay. Really a diverse panel today. Really, it really sheds a light on all the different angles, and maybe that's why we're getting so many questions. It's very good. We have 7 questions so far. Some are obvious who's going to answer, but if you want to interject, or I might throw it right at you, but if you want to interject, you can always raise your hand as a panelist. So the first one is for everybody. Could presenters talk about volumes of source water required, reused, and any challenges associated with that and solutions? So about source water. Does anybody something to say about that?
But can we get some clarification? Like when you mean source water, you mean the availability of or water intake as opposed to wastewater going out? Is there, if we're talking about limitations on source water, obviously you need a permit to take water. But I think in many locations, unless you're really rural, it often makes sense to use potable water from municipal supply, because basically you're just firing out a small diameter pressure line, so you can directly drill those as opposed to having a gravity sewer line. So quite often you'll find decentralized facilities that are just outside the urban area, maybe in a peri-urban area, that will use city water, but they'll have their own decentralized wastewater plant. So I think that if you're using well water, on the other hand, or if you're pulling water from a lake, there are lots of technologies out there that will help you bring that up to potable water quality. Whether you're trying to remove taste, color, odor, remove minerals, etc. So a lot of the technologies are very well developed for that. And we have been deploying those technologies extensively across Canada for many decades, for mining camps in northern Quebec, for construction camps in northern Alberta. So the technology is to take any kind of water and treat it to drinking water quality is well developed. In fact, if you look at the military installations, they have technologies that can take very badly very bad quality water, including some with chemical warfare agents, and convert them into drinking water quality. Canada sort of leads the world in those technologies. I don't know if that answers the question, but
I think so. I got a text affirming that you were speaking about what it was asked about.
okay.
So that helps. Next is a question for Josh in particular. Your system, Josh, is it on an individual or a communal or centralized? And I think what they're trying to ask is it dedicated to the homes that you mentioned, or are there other facilities that are using the system as well?
Yeah, so it's a bit of a unique situation. So the village of Carp is part of the city of Ottawa, but the village itself utilizes a big communal well. And from the village of Carp, we ran a trickle feed water main that goes to our private facility where we store it, polish it, repressurize it, and send it to just our subdivision, residential and commercial.
Thanks. Lindsay, did you want to add something to that?
As the operator, I can add, so actually this behind me here is Carp's facility. This is actually one of the eventually 2 above ground treated water storage towers that they will have to supply to the community. Like Josh said, it's a trickle feed off of the village of Carp. So the water being received from the village of Carp is considered potable, it's chlorinated. What's essentially happening is within the tank, and prior to it going out to the community in the Carp development, it's rechlorinated. So the operators in this case, it's more of a supply system than treatment, but it's still having to be incorporated and boosted. It's essentially a chlorine booster station to allow for water supply. And yeah, it's communal, decentralized, but it does go to the individual home. So people in the homes wouldn't know it any different from a municipal system and how it's delivered to them. It's just on the side of the operations that, we see it this way.
All right, thanks for clarifying that. And just a reminder to the attendees, if there are questions that you specifically like, upvote them, so we can take them in order. And here's one that's upvoted, and it is for you again, Lindsay. And there's a lot of acronyms in this, and I'm not from the industry, so I hope you get them. Do all of these 3 sites operate under ECAs with the MECP, and do they need to meet PWQOs for surface water discharge? So
okay, so yes, on the wastewater side, all of those sites have ECAs, which is an environmental compliance approval that is required for any site that is maintaining flows above 10,000 liters per day. That is mandatory across Ontario. The second you hit that threshold of 10,000 liters a day, you are put into the ECA process, which essentially is your compliance approval document that dictates out details out what the system is, how treatment occurs, the maintenance requirements, reporting requirements, sampling requirements, and the objectives and limits you need to meet on the quality side. So within that document, so CARP, being a surface water discharge, has really stringent effluent criteria on the treated side for wastewater. And it does need to meet, especially because I believe it discharged finally to the Ottawa River, which is a sensitive receiver. So because the new Terra facility is able to bring, it's really great treatment that's able to bring those limits really low, you're able to meet the provincial water quality objectives. And that's all considered in that ECA process and the document that we're working with to maintain compliance. Does that answer?
I assume it does.
Thank God I know my acronyms, right?
Yeah, to me it's clear as mud. Yeah, thanks very much for that, Lindsay. Here's another one and I've heard that one in preparation for this as well before, and this is for everybody. What is the typical minimum unit count needed for a decentralized system to make sense? And as a follow-up, does it differ based on municipal ownership, corporation like Quinte West, or a private system like the CARP condos?
I can take a first shot at that if you like, Marco.
Sure.
Yeah, we have actually built on-site distributed systems for very large private villas in the Caribbean, almost the size of a small community, but the private villa. So I would say typically, if you're less than, on a sanitary stream, if you're less than 10,000 liters per day, you probably aren't really considered a decentralized system. It's considered a typical on-site treatment plant, and you find a lot of different technologies there. Lindsay mentioned earlier that the technology on-site treatment or decentralized treatment is also used extensively for commercial and light industrial. And if you're dealing with a craft brewery, the wastewater from a craft brewery is 20 times stronger than sewage. And so you get the same impact on the environment from a very small flow. So a typical small brewery may have the same impact on the environment as 400 to 800 homes. And so it could be a small flow, maybe 20,000 or 10,000 gallons, 40 cubic meters per day, but it will still be a decentralized system because you can't put that back into the environment and you can't send it to a centralized facility because it will upset those. But I would say typically the smallest that would normally be considered for a decentralized facility is probably somewhere around 10 to 20,000 liters per day. But they do go up to several 100,000 liters per day. I think the largest I've built, which was a decentralized system, was probably 7 million gallons per day, which is roughly 28,000 cubic meters per day. And it's still considered a decentralized. It was a privately owned facility that treated water for a country club next door. So.
All right, I see Lindsay, you want to add something?
Yeah, I just wanted to add to that. So looking at the question, Jim's right. So I think over 10,000 liters a day is really kind of your kickoff point where decentralized makes sense in the way we're talking about. In the count or in relation to development, like for example, for carp, you don't start with all the homes built. It comes in phases. Occupancy also doesn't happen all at one time. So in a lot of the ways in which operation needs to happen too and how things are phased out, it's really sort of a metric of what the system is ultimately designed for and what your current flows are. So you're usually looking for around 30% of your design flows for that phase before you're going to go into the actual operation of the system where you're going to be operating in that sense. As far as like, does it differ based on municipal ownership and operation versus private? There are definitely differences. Ultimately, the end goal all looks the same. There's slight differences in like the regulation and documentation that needs to be followed, but the level of competency and quality that you have to meet in that treatment, maintenance, and operation is universal across the board.
Thanks for that. Another question that is here is, are these communal systems more beneficial to rural areas located close but outside of a large urban area where there are some municipal water and sewer services in place? My concern is smaller municipalities with no municipal services do not have the people or resources to ensure proper installation and maintenance. And in the same way, smaller municipalities would not be able to assume the communal services in the event of a default.
Okay, so I'll speak a little bit to this first. So communal systems, they are typically in rural, but I will say we also have communal systems that are within urban boundaries because development was occurring and the current municipal infrastructure no longer had capacities to support that further development. So you kind of see it in both aspects where you may still have communal systems in place or decentralized systems in place, even where you have water and wastewater services available. With respect to the smaller communities, those are very valid concerns. But this is where you start looking at between even the private side and the municipal side, like Quinte West having operations that's municipal in-house. or having municipal operations to service their facility, you start to look almost at shared services as well. I can say pretty confidently that across the board, labor is definitely a challenge. Having enough operators is definitely a challenge, whether that's municipally based or private based, the way Clearford operates. We've actually started to even look at opportunities, like I said, where there's shared services or support services between operations, because you do want to make sure the proper operation and maintenance is available. You know, and I do know we've been talking to some smaller municipalities. They're looking at sharing services amongst the neighboring smaller municipalities in order to be able to provide sort of some of those shared services. So like the compliance side of it, or even the operations side. As far as default, that is always typically the concern if you have development that the municipality is going to have to retake that development on in the event of default. I can say there's only maybe a handful of cases in Ontario where a system has actually defaulted back to the municipality. But, you know, every effort is made on the part of the operator, the developer, the condo corporation, or whoever's running the property, to ensure that everything is done in order to not have default occur.
Well, thanks, Lindsay. We have all the other panelists with their hands up. So we're going to go in order of how they came up. And it's Jim, and then Chris, and then Josh.
Yeah, I think labor or the access to decent operator capabilities is critical, but there are very successful decentralized plants operating in extremely remote areas, you know, from the outback in Australia to systems that are working in downtown Santa Monica in California. You know, so I think there are really good examples of how the technology can work. It really comes down to how the systems are designed, because you know, if you design with a lot of remote monitoring and interactive capability, you can actually monitor a lot of these systems from a distance. You know, we monitor, you know, 24/7 a system in the Central Valley in California. You know, so we can monitor those things, these systems today. You know, so I think the technology is amenable to pretty well any location, but you do have to take into consideration how they're designed and what type of operator control is required.
Thanks for that, Jim. Chris, did you want to add something?
Yes, thanks, Marco. And further just to Lindsay's comment and Jim's comments, in the two cases I sort of mentioned in Quinte West, Stonecrest, and then Young's Cove, these were sort of extensions of our urban areas. So both these areas were serviced by municipal water and didn't have sanitary sewer capability. But with partial service development being limited throughout the province, it didn't make financial sense for the developer to extend sanitary sewer services all the way from our larger 3 facilities to these areas. So we looked at these partnerships with a developer to facilitate development in those areas, and knowing there's a housing crisis out there all across the country, looked at these partnerships with developers to support these sort of decentralized facilities at 2 locations to support all of this growth that's what we wanted to happen in our municipality.
Thanks for that, Chris. Josh?
Yeah, the only thing I would add to what Lindsay was saying about default is that if the developer or the condo is going to be the ones owning the facility as part of the municipal responsibility agreement, there's typically a fairly large security that the developer has to put up in case of default, which would be used by the city or municipality to pay someone like Clearford to operate the plant if they ever did go into default.
All right. Thanks everybody for your input. Probably a quick one for Chris. Chris, do the Quinte West systems have MRAs, so municipal responsibility agreements? And I heard Josh talk about that, since there are full-time residential housing.
Thanks, Marco. No, we do not. Right from the start, the Stonecrest plant was built such that it would be operated by the municipality, because we operate 3 larger facilities in our municipality, and we also have 4 waste or water treatment plants that we operate in-house. So we didn't need to have an operating agreement with for that system. The Young's Code development, as I mentioned earlier, we don't have an MRA, but we did have a subdivision agreement that really outlined this collaborative relationship with the developer so that they would supplement the difference in the cost annually until the plant was sustainable, and we assumed it. So as we were receiving revenues from houses that were being built and people were connected to the sanitary system and paying wastewater charges, that difference in cost between the operating cost and what we received in revenues from the users, they contributed that difference back for about 8-9 years until the plant was sustainable. And at that time, we assumed ownership and responsibility for it.
Thanks very much, Chris. We're going to try to squeeze in one more. Hopefully we can. We have about 3 more minutes to wrap it up. But one more question that we have is: are you aware of any of these types of decentralized systems that have the flexibility to add a PFAS treatment?
No.
That's-
Well, I think the problem is that we don't really know from a technology point of view what is the optimum treatment technology for PFAS removal. You know, there are right now a lot of water and wastewater companies. You know, they have a range of technologies that are being used and pretty much on a proof of concept basis. Granulated activated carbon seems to be the dominant one because it's the cheapest. And you know, it can remove some of the PFAS elements that are of concern. But you know, literally, there are tens of thousands of PFAS chemicals. And we've pretty well only studied maybe 100, 200 at most. And we only have epidemiological data on maybe half a dozen. You know, so it's still an evolving issue. So you know, whether it's granular activated carbon or electrochemical reduction or any other type of technology, they're still evolving. There are a number of companies though that do have mobile treatment plants that they can bring out to basically pilot how it would work on a particular stream. But I would say on that one, it's stay tuned. It's something that's evolving over you know, probably the next few decades. And it also depends on the administrative environment. Europe is bringing in really tough PFAS standards. It looks like the US is moving away from them a little bit. And so it's hard to get, you know, a lot of industrial commitment to the technology where the potential revenue stream may or may not be there for the foreseeable future.
Just to touch on what Jim's saying as well, I would say in conferences, it's a very hot topic. PFAS has been a hot topic for a while, but it's garnering right now a lot of attention. So you do have a lot of equipment suppliers who are looking at different options to treat PFAS and how that's going to be done. As far as how it adds into the systems that are already in place, that's not necessarily there, but there is the work and development, like Jim was saying, to create optimal PFAS treatment. But that's all going to sort of depend too and probably be driven by the regulations. A lot of times things aren't just being done because it feels good. They're going to do it because regulations are put in place to sort of force the hand of that. But we are seeing that's likely the direction it'll go.
All right. Thanks for that. And thanks for all the questions. There are more than we can answer, and we've promised that we will address them afterwards. That might take us a little while, but we are noting them, and we're going to get back to you with the answers of the questions that we didn't get to. So Once again, after this recording, you will be directed to a survey, and we really hope that you provide us with the feedback. We use the feedback from your last survey results in this one. In a few days, you will also receive an email with a follow-up and a link to the webinar on YouTube. And thanks again to the panelists and all of you in attendance, and have a great rest of your day. Thank you.